Hello everyone. Today we are going to talk about standard SID1. In this standard it says that I can represent data with plots on the real number line, dot plots, histograms, and box plots. You should be looking at your day one notes in your interactive notebook guide, and at the conclusion of this lesson you should complete your day one assignment. The first type of graph that we're going to look at today is called a dot plot. A dot plot is a line plot that can be used as an initial record of discrete data values. The range determines a number line which is then plotted with X's or dots for each data value. An advantage of the dot plot is that it provides a quick analysis of the data. It shows a range, minimum and maximum, gaps and clusters and outliers very easily. Exact values are retained. A disadvantage is it's not very visually appealing. It's best for under 50 data values, and it needs small range for data. Okay, so these are our disadvantages right here. The biggest advantage of the dot plot is that the exact values are retained, and you'll see what I'm talking about in just a minute. All right, so here's our first example, and this example did a really bad job of providing labels for the graph, so you really don't know what they're looking at. When I look at this example of a dot plot, I just think of kind of a random question. Say I stood outside of Walmart, and I just asked people walking in, how old are you? So one person said they were 30, two people said they were 34. If we look here at 40, three people said that. 47 looks like they have 6 people. So that's what a dot plot is. Exact values are retained, and you just make a little X for each data value. Here's the second example that's in your packet. And in this one, it's asking how many brothers and sisters do you have? So when we look at this, it says 2 people said they had 0 siblings. 3 people said they had 1. 5 people said they had 2. 2 people had 3. And 1 person had 4 siblings. Okay, it is an advantage to make a tally box chart like this first before you go to your graph. Okay, so this is our data that's represented in our frequency table here, using a tally chart to just kind of count them up. Okay. And if you see, we had 4 students with one student with 4 siblings, and then that's represented here, 4 siblings, and 1 person said yes. The next type of graph we're going to look at is a histogram. A histogram is a type of bar graph that displays continuous data in ordered columns. Categories are of continuous measure, such as time, inches, temperature, etc. An advantage to this is it's visually strong. It can be compared to the normal curve. It usually has a vertical axis that is a frequency count of items falling into each category. A disadvantage of a histogram is you cannot read the exact values. So in the dot plot, I was stating that the exact values are retained, but really in the histogram it's lost. Okay, it's more difficult to compare two data sets, and you use only with continuous data, and you'll see what I mean on the next slide. In a histogram, data are grouped into intervals of equal width. So this right here, equal width, is kind of important. The number of data values in each row or in each interval is the frequency of the interval. And to draw, you begin by making a frequency distribution. Okay, so the frequency distribution is a lot like the tally chart that we just made a bit ago. Okay, here's an example of a histogram. Okay, not the most interesting example to look at, but an example. Here we have ozone ranges, and if you notice, it's saying 0 to 0.09, and then the next range is 0.010 to 0.019. And when we look at this, this is measured in 3,000s. So you have 3,000, and the next jump up is 6,000, and it's measuring the number of hours. So although the data looks very small, it actually, each one of these is counting by quite a bit. So it represents a lot more than what we would think, but pay attention to this down here. It groups the ranges in this area, and then it makes the bars. That's how many times it occurs. Okay? This histogram is a little easier to read. This is talking about student grades, and it says this is the number of students. These are their final scores, and here are their percents, basically. So if we read this, we can say that 1 person got a score of between 20 to 29. Okay, it's grouped them. 2 people got a score between 30 and 39. And if we went over here, it looks like most students, the most students occurred here between 80 and 89. Okay, and it looks like we have 13 students that scored between 80 and 89. So now we have to make our own. Okay, and for this, I'm going to use the handout that is directly in your packet. And I'm just going to count them up, and I'm going to make my tally marks here. Okay, so how many things happen between 40 and 49? 1, 2, 3. 1, 2, 3. Mark them out. They are used. The next thing we jump to is between 50 and 59. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, mark them out as you use them. Between 60 and 69, I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I mark them out because they are used. Okay. Now I'm looking at numbers that fall in the range of 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, we move on now to the scores that fall between an 80 and an 89. Sorry, not scores, free throw percentages. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Between 90 and 99, there's only 2, much easier, and 100 has only 1. Okay, are we good? I think so. Now we're going to take this information and we need to translate it onto the bar graph. Okay, so hopefully you have these tally marks here because I am going to start graphing here. When you graph them, you're just making bars, but you need to be very careful. Your bars need to actually touch each other because it is a continuous set of data. And remember, one of the directions stated that our bars need to be kind of equal width. So I'm going to make my bars kind of wide here because I gave you guys lots of space. So I'm going up 1, 2, 3, and I'm going to go like this and come down. My next bar happens between 50 and 59, and it needs to come up to the number 9. So starting here, I'm going to come up to the number 9, try to make it of equal width, and come down. Okay, then I get to 60 to 69, and this one is saying it has 17. So I need to take this even higher now, all the way up to 17, about right here, and trying to make it of equal width. We're not going to break out a ruler and measure, but of equal width. Okay, then the next one we have is 16. So we are only one down. Okay, so just slightly down, trying to make it of equal width. Now we are looking at 80 to 89. There are 9 of them here, trying to make it of equal width. Between 90 and 99, only 2. Then we kind of finish out with just 1. Okay, and that is an example of a histogram. All right, the next thing we're looking at is a box and whisker plot. A box plot is a concise graph showing a 5-point summary. Multiple box plots can be drawn side by side to compare more than one data set. An advantage to this is you have a 5-point summary and you can very easily see the outliers. It can also be used to compare 2 sets of data easily. It handles extremely large data sets, but a disadvantage is it's not visually appearing and the exact values are lost. So there are 2 types of graphs we've discussed today where exact values are lost, and that would be the histogram and the box and whisker plot. Only the dot plot keeps each individual set of data, and that's why they said they didn't want the dot plot to be more than 50 numbers. Okay, a box and whisker plot is a box that encloses the middle half of the data and whiskers extend to the minimum and maximum data values. I'm sorry that you can't see everything on my screen, but you do have this in your packet, so hopefully you're following along at this time. All right, we have some very specific steps for making our box and whisker plot. Step 1 is you need to order the data from least to greatest. Step 2 is you need to find the maximum and minimum values. Step 3, you need to find the median. Step 4, you need to find the upper and lower quartiles, which are just medians of the upper and lower half. You're going to plot these 5 points on a number line, then you're going to draw a box and whiskers and a line segment through the median. Here are some examples of a box plot. Okay, my daughter is a junior at the university this year, and her and I were having a discussion about box plots, and she said never in her high school education was she taught a box plot, and now she sees it in her statistics classes. So it's a very simple thing, but if you look at it, it could be quite confusing because, you know, what really is happening here? Well, hopefully after you draw one, you can see what happens. But this is comparing 3 different design companies. Okay, and here is our first example. Now, we need to arrange these numbers as step 1 stated from smallest to biggest. So I'm going to kind of take my time on this. I know that 17 is my smallest. And then I'm going to survey everything. And it looks like 24 comes next. After 24, we jump to 25. Okay, and then just looking through everything again, it looks like 30 comes next. After 30 is a 33, and then a 34, and then a 36, and a 37, and a 39, and a 40 twice, so we have to list it twice. And we're ending with a 42 and a 48. I like to mark things out as I go. I think it helps me keep track of what's been used. All right, once you've done this, you need to find 5 exact values it stated. We are going to start with our extremes. The lower extreme is the lowest number. So our lowest number is 17. The upper extreme is our highest number. Our highest number right now is a 48. Okay, the next thing we need to do is find the median. And the median, when it's arranged from smallest to biggest, is just the middle number. So I'm just going to go like this and start covering them up. So here, 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 36. My median is 36. Okay, once I know this is 36, I had an exact middle value, it's 36, then I'm going to look here. And to find the upper and lower quartile, you have to find the median of the bottom and top half. So the lower quartile, you go here, here, here. I have 25 and 30. Well, there's 2 numbers in the middle. So what do? I add them together and get 55, and I divide by 2 to get 27.5. Okay, the last thing I have to do is find my upper quartile. Okay, and my upper quartile is 240, so 40 plus 40 is 80, divided by 2 is 40. Now we are ready to draw our graph. Okay, our graph is just a number line. 17 is the extreme, and so is 48. So those numbers go on our number line. And then you have to kind of figure out, well, where's 36 land? Well, 36 is 19 spaces away from 17, and 18 spaces, nope, only 12 spaces, sorry, away from 48. So 36 is probably going to be a little closer this way. Okay, then the next thing is where would 27.5 fall between these two? And it's pretty much right in the middle. It's pretty close. Okay, and 40. I'm not going to break out a ruler and measure you, but you do need to kind of estimate where numbers go. If you don't feel comfortable estimating, you can just draw a whole number line and plot all the numbers. Okay, your next thing to do is draw a box from the lower quartile to the upper quartile, and then draw a line through the median, and that is a box and whisker plot. What is the purpose of the box and whisker plot? It splits it into 4 sections, and each section is said to hold 25% of the data. So if I asked you a question like, how many people got between a 40 and a 48, you could say 25% got that. Or how many people scored lower than a 36? You can say 50% because lower than a 36 is these 2 sections. So that is the benefit to a box and whisker plot. What's lost is the individual sets of data. We no longer have all these numbers. Now we only have 5 numbers. So it's been replaced. All right, example number 2, we're going to do exactly the same. So we're going to start with the lowest number. My lowest number is 61. Mark it out, it's been used. Okay, after that I see a 62. Mark it out, it's been used. From 62, I get a 64. Mark it out, it's used. After 64, the next number I see is a 69. Okay, after 69, looks like I'm going into my 70s, and I only see 76, but I see it twice, so I'm going to mark them out. After 76, it looks like the next number, those were my only numbers in the 70s, I would have an 82. I have an 82 once. I have an 82 twice. After 82, the next number that I see is an 85. Here's my 85. Okay, then I have an 87 and another 87 and yet again another 87. Okay, now we are into our 90s, starting with 90. Here's 90. Then we have a 92. Mark it out. A 94. Mark it out. And a 95. All right, these are our numbers from smallest to biggest. We need to find 5 values. We need to find our lower extreme, which is easy. It is 61. We need to find our upper extreme, which is equally as easy. It is now 95. Okay, but we do need to find our median. And we're just going to work our way in again. So here, 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 here. Oh, I've got 2 numbers in the middle. Okay, 82 and 85 it's looking like. So I would take 82 and I would add it to 85, okay? Or you can simply think of what would be in between here. Well, there's 3 spaces apart, so split the difference, 1.5, 83.5 is in the middle, okay? And I'm just going to recount these really quick to make sure I started with an even number of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, because there's an even set of numbers, we are going to have 2 numbers in the middle, okay? Which makes then our lower quartile and upper quartile calculated a slightly bit different. Okay, because we have 2 numbers in the middle, we're going to split it. This is our 83.5, right? But we're going to count here, and we're going to do our lower quartile. So we go here, 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 69 and 76. 69 and 76, there are 7 places apart. Half of 7 is 3.5. We add it, 72.5. Okay, then we need to do the same thing to the upper half. So we go here, 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 87 and 90. 90 minus 87, there's 3 places. Half of 3 is 1.5. Add it, 88.5. We now have our 5 data sets and can make our graph. 61 is your lower extreme. And my upper extreme is 95. In the middle is said to be 83.5, but 83.5 is actually a lot closer to 95 than it is to 61. Again, I just kind of estimated where I was going to drop that point. The lower quartile is 72.5, and I could say that's halfway between these 2 numbers. But then the upper quartile is 88.5, and yeah, you know, that's pretty close to being halfway in between those 2. At this time, we can now draw our box. And there's our median number. That is our box and whiskers. Again, remembering that each section is worth 25%. All right, this is the conclusion of Standard SID 1. At this time, you should be looking at your homework assignment that relates to this standard. Thank you.